Hello and welcome everyone to the Android Kotlin Multiplatform 100% online event today. For those of you in the region here in Europe, I can totally understand that you prefer to be outside today, um, having switched from springtime last weekend and today we are migrating almost from 0 degrees to 20 degrees of sun here in Lausanne. But I assure you that we are here now for a very good reason. So do stay with us for the next 60 minutes because the day will not feel so complete as we have Roberto Oggio here with us tonight, our distinguished speaker for today, joining us all the way from Turin. Roberto is currently working for the New York Times. He's a senior developer there, and as you can guess, an avid fan of Kotlin. So just before I hand over the microphone to Roberto, a quick introduction of GDG Lausanne. For those that managed to come in, we had apologized now. We had a little bit of problems with the meetup event. Google is trying to migrate all the events away from Meetup to their own platform. So firstly, thank you for coming to our first ever event for 2021. My name is Ben Bay. I'm one of the co-organizers here. GDG Lausanne is here very much to promote good tech, to grow and engage with the developer community here in the region. We also sometimes hope and try to believe that we can be also the bridge for non-developers and also for business interests. So folks that are interested in tech in general. We're also quite new, so if you're interested in joining us as a co-organizer, or if you feel that your business is interested in sponsoring one of our events, feel free and don't be shy to reach out to us at any time today or in the near future. Yeah. So without further ado, I do like to present Roberto to take the center stage. Roberto, are you ready?
Yep. Hello, everyone, and thanks for being here. So, let's get started right away. So, this talk will last more or less 40 minutes. We will have time for questions at the end. So, okay, let's get started. Okay, yeah, it wasn't really started yet. So, tonight we're going to talk about Kotlin multiplatform and basically how to get started from an Android developer point of view. So before we really dive deep into the topic, I wanted to share with you some premises. So the first one is that I am an Android engineer. I've been doing Android for a lot of time now, and that's what basically defines me work-wise. Also, I don't really want to be a cross-platform developer. I know that a lot of solutions came out in the past years. Was there when we used jQuery mobile, then it evolved in PhoneGap, and then React came, and then Flutter and everything. Yeah, it doesn't really interest me that much. Also, and this is the last point, I have a little bit of knowledge that I really want to reuse. Because, of course, I don't want to throw away the last 10 years of my career. So, these 3 points bring us to only one solution, which is using Kotlin. So, why do I choose Kotlin? Well, Kotlin was only one of the choices because I could have gone with Flutter, and that would have been mostly the same, except I don't really like Dart. Probably if I used Dart before Kotlin came out, I would have loved it. But since Kotlin is here, well, but there is a downside of this, and it's the fact that by using Kotlin multi-platform, we still have to deal with Swift. which is fine, more or less, unless you have to deal with Xcode for a long while. In that case, I'm sorry. I tried to use Xcode for a couple of hours and I ran back to Android Studio screaming and crying and thanking JetBrains for the amazing IDE they made. So, um, for this project, I decided to build a small app that will tell me the lights of the Empire State Building because they change on a daily basis. There is no real API, so the project was a bit more complicated than the simple app. But this is actually what we'll base our example on this time. But it can work with everything. I mean, after all, we're gonna see the core part of Kotlin multiplatform and how to integrate it in two platforms. Um, so, as I mentioned earlier, the app are only a small part of the project because the first part was to basically scrap the data from the website because well, there was no API, there was no REST endpoint, there was no endpoint at all. Everything was hard-coded in a web page. So, yep, Ktor helped a little bit. The UI on Android has been built by using Jetpack Compose, while the UI on iOS has been built using Swift UI. Why did they pick up these three elements? Well, basically because Ktor was easy. Jetpack Compose well is new and shiny, and Swift UI because yeah, I have to use Swift, so at least I can take the good out of it. We won't really explore these three aspects because it will require well over 1 hour to explore them all. But we're gonna see some small bits that are most interesting for the topic. So first, let's take a look to the architecture of a normal app. That's based on Android just because I have more experience on Android, but it doesn't really differ that much on iOS. So the first thing that we have when we start creating an app is an activity. And we all know this is deeply Android, tightly connected to the system. You can't get rid of it, and well, you just have to deal with it. Then we have most probably a view model because that's the way we should go. That's where we should put our all our code and everything that is not UI related. This again, of course, comes from Android. The next layer, that is the one that we should have more cross-platform than ever, is the repository. So what I mean with repository basically is the piece of code that will give the data that the view model will process to then uh, give me the models for the UI. So it's everything that has to do with network connection, storage, and everything else that is not really dependent on Android or iOS and can be shared outside of our Android app. And of course, the last part is the backend because, well, we need to have APIs somewhere. So we target the repository as our main part to share. And well, we shouldn't have that many dependencies on Android. But well, it's not really like that because if we have a REST endpoint and we deal with JSON, it's highly possible that we're using retrofit, JSON, or Moshi. But there's a catch. Those libraries are not yet compatible with Kotlin multiplatform. But but there is a good news, which is that we have multi-platform library available and are Ktor and Kotlin X serialization. Ktor is the same, but let's say that is the same library that we use for the server. It has several modules. This way, in this case, we're going to use the client, while on the server we'll be using the server module. And Kotlin X serialization is a new library that basically replaces JSON and Moshi. It's very easy to use, and it comes from JetBrains. Both actually comes from JetBrains, so we should trust them. So, given that we switch from Retrofit, JSON, and Moshi to Ktor and Kotlin X serialization, we can really say that now our repository is ready to be multi-platform. So what we have now is the activity and view model. So basically everything that is UI in the native app module and the repository in the shared module. And of course, while we still could write the native module in Java, we should not, but we could. But if you want, you can, but you shouldn't, because Kotlin. The shared module has to be written fully in Kotlin. Okay, it doesn't change much from normal Kotlin or Android Kotlin to Kotlin multi-platform, especially if you are doing something normal like the repository. Um, well, you can reuse all your knowledge. So let's see a bit more about the Android app. So the first thing that we need to do is setting up a project. When I first started looking at Kotlin multi-platform, well, it was quite complicated to set up a project because you need to do everything by hand. Luckily, now there is a plugin for that, which is called Kotlin Multiplatform Mobile, and it comes directly from JetBrains. It can be installed on Android Studio or IntelliJ IDEA, and just need to restart your IDE, and everything is ready. At that point, you'll notice that when you create a new project, you just need to scroll all the way down to the last item, and you see that you'll have a KMM application, which is a Kotlin multi-platform mobile application. When you click next and you follow all the steps, you'll find yourself in this window. In here, you can define the name of the three modules that you're gonna need: the Android app, the iOS app, and the shared module. And the nice thing about this plugin is the fact that all directories and the tests will be created automatically for you. So you don't have to create anything by hand. Everything is gonna be basically done by the plugin. As soon as you hit finish, it's gonna do all the Gradle sync, probably increase the temperature of the home by 25 degrees because, well, that's Android Studio. But then everything will work almost flawlessly. Let's write some code. The first thing you notice as soon as you open your window is most probably an error that is related to some Kotlin multi-platform specific feature, which is the expect or actual dualism. Well, this is not an error. You just need to wait Gradle to finish all its magic, create all the folders, because normally it will create the Android folder and then the iOS folder. But for expect and actor to work, you need both of them to be created. Because while expect tells that our function will be implemented in the native module, we need all the native module to define it as an actual function before it can be recognized. You just need to wait a few minutes and everything will work this time. Serious, everything will work. So now that we cleared and we wait for Gradle to sync, we can start checking the models that we need. For this project, I created two data classes. They are really simple, and let's start from the first one. So, a fun fact about the Empire State Building is that every light has a reason for being of that colors. For instance, on Columbus Day, the Empire State Building will be enlightened by green, white, and red lights. Um, then there will be there's been the celebration um, for many sport events, and basically every major event that occur in the world can be celebrated with with the lights of the Empire State Building. And this is why we have a reason field. You might notice that the color is expressed as a string. That's because the website doesn't really give you a color, but gives you an idea of the color. Like it can say something like clear blue or deep red, which is okay, but it's not really parsable easily on Android unless you know all the values. And the date, well, the date should have been a date, but I was slightly lazy when I created this model and I didn't really parse it. There is a JetBrains library for that as well. And it's called, if I remember correctly, Kotlin X date. Should be in beta right now. It's fairly easy to use. But let's continue with the models. So this first model represents the lights that will be in the calendar from tomorrow to 3 to 4 days afterwards. The next model represents the response that we get from the server, basically, and it express the color that the Empire State Building will be enlightened today, a URL for the picture, and the list of the next lights that will come. You might have noticed the add serializable annotation. Well, that comes from the Kotlin X serialization library, and it's basically everything you need to serialize your object with that library. So we have the models cleared now. This is all the models that we're going to use. And let's check how to make a network request. Well, for everyone that is familiar with retrofit, this is way different from what you would expect with retrofit. You don't have to create basically anything in the same way because the first thing that you need to create is an HTTP client in which you're going to install a JSON feature. And that JSON feature, you're going to add as a serializer the Kotlin X serializer. That serializer has been built with the ignore unknown keys flagged to true because otherwise it would try to interpret the JSON in a strict way. That means that if you don't declare a field that is instead in the answer from the server, then your app is going to crash. Since I didn't need all the fields that I created in the backend, I set that to ignore unknown keys, and that will do the trick. At that point, we can create a normal suspending function, which is called getLights in our case, which returns a model exactly like it will do in retrofit. And what we do is taking our HTTP client that we just created and call on it the get method. The get method is not a getter for the object, but it's rather the HTTP get. So you would have get, post, put, delete, and everything else. And something that I don't really like that much is the fact that we need to pass in the endpoint for our request. This is very different from retrofit, where we could just basically add the URL in the annotation and everything will work. Of course, there are two different libraries created in two very different ways, but this one works with Kotlin multi-platform and it's easy enough to use. So there are pros and cons on both. So again, this is the repository. It's very simple. It's basically just built um, on top of the Ktor client. We could add here the storage with the SQLite database. It's not the case because we don't have that much data and lights will change every day. So that's our repository basically. Once we have the repository, we can add it inside the view model exactly like we would do with any other library. Since our view model is inside the native app module, we could use any dependency injection framework. So it could be Hilt, it could be Coin, whatever you feel like. This is in your native app. So as long as you can build the light repository, you can inject it as much as you want. In here, in the example, I didn't use any dependency injection because the light repository was easy enough to build without any external dependency. Of course, if I add a SQLite database or a strategy to save and delete data, I would have had to inject it, but it is fairly easy otherwise in this case. Going on, we have two live data. This pattern is not really needed. It's out of habit to get a live data which is not mutable outside of my view model, but it would have worked in the exact same way if we used the live data and set the value instead of calling post value. So let's focus a little bit more on the actual call to our repository. So the first thing we're gonna do is emitting a loading event. This comes from the LC pattern, which is fairly useful when dealing with UIs and operation that can take a bit more and are blocking. We don't have data, so we want our user to wait. So we wrap our results and our errors inside objects that are the loading, the success, and the error. Well, success would be complete, but I prefer success. So instead of LC is LSE, but the paradigm is that one. It's also helpful because since you have everything contained inside this sealed class, because that's how you want to create an LCE, you don't have to manage states because every time you want to update the data, you will basically start from loading, get in either the success or the error, and you can continue in this way. You don't have to manage that from the outside, it's self-contained. At this point, since we are in a view model, we're gonna launch our coroutine and invoke the getLight on our repository. In case everything goes smoothly, we push our response inside the success and we post that to the live data. Otherwise, we push the error into an error state and post that. But that's really exactly how you would do that on Android normally. So from this point on, Kotlin multi-platform is already down the pipe. We don't care anymore. This is Android, so we are already familiar with what you're doing. So now we are back in our activity. We take the view model as we would do normally. And we observe the state of the live data. But the integration with Compose happens here. So inside the observer for the live data, we're gonna set the content of the UI and create a composable UI, which is called Lights UI. And then we just invoke the loads UI to load all the data. But even if that was slightly easier than I expect, there is something that might go wrong anyway. The first thing that happened to me is this error, which was quite scary to be honest, because it looked like Android Studio couldn't recognize my shared module. Well, the solution was fairly easy, I'd say. So just have to close the project and the IDE, delete the .idea directory, delete all the IML files in the project, and then re-import it. I have to be honest, it didn't happen to me all that often, probably just 4 or 5 times while developing the sample, but it got better with the newer version of Kotlin Multiplatform, and it didn't really happen recently. The next error that I got was even scarier, and well, it was asking me to initialize at least one Kotlin target in the shared module. I didn't have a clue. I mean, it was like, well, it was initializing yesterday, but yeah, I updated Android Studio, and that's exactly what broke everything. So the solution was inside the issue tracker of Kotlin, and it was as simple as updating to Gradle at least 6.7. So in case you want to start with Kotlin multi-platform, remember to not use an older version of Gradle because otherwise you're gonna have weird errors. Now let's switch gears to iOS. So again, I'm no iOS engineer, and I needed help to create an iOS app. There is this fantastic code lab from JetBrains, which teaches you how to create a simple UI with Swift UI, save the data with SQLite, and make a network call. So make sure to check it out because it's really, really interesting. And yep, now that I did the introduction, let's go to the most interesting part of iOS, which is using coroutines. I have to say that I tried to be a bit naive when I started to develop on Xcode because I wanted to use coroutine in this way. So I knew that my Kotlin file was common, so I just invoked common KT. Then I noticed that there was an iOS scope method, and I tried to invoke a launch function exactly as I was doing on Android. Yeah, turns out you can't really use coroutines in this way because, yeah, of course, I knew they were declared as extension function, and yes, I totally forgot that they were declared as extension functions. So this is not the right way of using a coroutine on iOS, but it's slightly more complicated than that. So um, what we need to do on Swift is creating a view model, which is an observable object. I can give you the details because it was the first time I saw it, and it really looked similar to Android. So you need to declare your repository. Again, it's called light repository because this is the same that we created earlier in Kotlin multi-platform. And then you need to create an object which is marked with the @published annotation that works more or less in the same way that live data works. Is basically an object that respects the observable pattern. So when it has new data, it will push it to you and to all the listeners. And then you just need need to init the repository bypassing, or the view model, sorry, bypassing in the repository as a dependency in the init method. Of course, as soon as you init the repository, you want to load the lights. It's important to notice that the loadable lights enum that you can see on top, close to the extension content view declaration, really is similar to what we would do with the LC pattern on Android. What changes? Well, here we have an enum with cases and the data that we can push down the line. While on Kotlin, we would create a sealed class that would contain an object for loading and two classes for result and error. An object for loading because loading doesn't give you data, so it doesn't require us to create classes every time. It can be an object, while the result will give us data, so we need a class, and the same goes for the error. So now we created the view model, we got the light repository, and we create the iOS equivalent of live data. But we didn't actually get the data just yet. And this can be done in this way. So the first thing is, again, emitting the loading event. And then we have our call to coroutine, to our coroutine. And that's the second line of the function. So basically, it will work more or less like it will work with Java. So you will invoke the getLights method and pass in a completion handler. That is a bit strange, in my opinion, because it will give you as inputs both the result and the error. So at that point in the Lambda, you can say that if you have the first parameter, the lights, then you can push the result down the line. Otherwise, you'll get an error. Is it easier than Android? Probably, but I'm biased because I've been using Android for the past years, and it was the first time I saw an iOS. I have to say that it's pretty intuitive, though. I don't really like the idea of passing a completion handler. I didn't like it in Java, and I don't really like it in Swift. I prefer how we would handle coroutine in Kotlin. But it is fairly simple to invoke a coroutine from Swift as well, so that's good enough for the moment. So we saw how to create an observable object that would push the loading, result, and error. We saw how to invoke a coroutine, but we didn't see how to connect these to Swift UI. And this can be done fairly easily by just listening to the iOS equivalent of the live data, the published var. In this case, in this way, when we have a loading, we're going to create a loading view. You can see the any view text loading. If we have a result, we create a lights view, which is more or less similar to the lights UI on Android. And when you have an error, we have a view that describes the error. The nice part about this pattern is the fact that, exactly like the LC on Android, if we put a retry button in the error, it will just restart from the loading, and again it will follow the same path. So you will have a flow that is always in the same direction. So it's really useful, I think. So now I wanted to just show a little difference from Compose to Swift UI. So that's why we have both Android and iOS logo at the same time. And the difference is in how we declare our objects. our composable or our composable equivalent on SwiftUI. So basically, everything is part of a parameter in the constructor in Compose. You see that we have text, color, all the modifiers, and the letter spacing, and all a bunch of parameters that can be added in the text right there in the constructor. While on SwiftUI, the text parameter will mostly take only the label that it's going to show, and then everything else will be chained below. Uh, Probably the one on SwiftUI is easier at first glance, but I prefer the Kotlin approach, as you can compose all the different pieces one inside the other without any problem. But if you look at them, they're pretty similar, and there is no real big difference in creating a layout for Compose and SwiftUI. So that was just what I wanted to highlight. So at the end of the day, the app that we created looked like that. We had a reload feature on both, thanks to the LC pattern. And what we have is the lights for today that is shown in the upper part of the screen, and the lights for the next days that will be in the lower part of the screen, and that will be shown as a carousel. So if you are more interested in how I created the server and the two apps, everything is on GitHub, and you can find me on Twitter, and you can ask me for clarification or for slides if I ever forget to publish them. I hope that I remember right after the talk. And that was it. It's now time for questions. Thank you.
No, thank you, Roberto.
Thank you.
Now we'll take some questions if there's any. Let's check the chat. There's one. Do you have examples of apps in production that have already been made with Kotlin multi-platform?
Yeah, there are a bunch of them. I will need to check. But the fact is that it's harder to find Kotlin multi-platform real-time examples that are already in prod because it's new. It's very new, so it has been in beta only recently. Probably it will become stable later this year when Kotlin 1.5 comes out, if I'm not mistaken. I'm not 100% sure. While it's easier with Flutter and React because they've been stable for the past years. So there are a bunch of them, but I don't really remember them all. There are not that many, to be honest. But if I were to be honest, I'd rather try to deal with the possible errors that comes out of Kotlin rather than dealing with a whole new platform that I'm not familiar with. That's of course biased, and that's again from the premises I don't want to be a cross-platform developer. Probably I would think otherwise if I wanted to be a cross-platform developer. But no, I can't remember many of them.
Yeah, maybe I can add to that. If I'm not mistaken, when I did some investigation some weeks ago, uh, I think it was Pinterest or Evernote, or yeah, that uses Kotlin on their apps. But I'm not exactly sure. But I'm sure if you Google, you'll probably find the answers somewhere.
Yeah.
Other questions, since we don't have any others on the chat, Roberto, is that um, the when I was learning Flutter last year, um, actually, yeah, as we went into lockdown, the pitch was that you save about 20-30% of the time, development time. And obviously, it depends on what you do. And if there are libraries that support it already, Google has been pushing quite a lot of widgets and supporting libraries. Um, how about Kotlin? If is there a comparison in time saving? If I was supposed to do an app from scratch using Flutter and Kotlin, what's the time difference?
I would say that it depends. It depends on your team composition, your team expertise, and the task that you want to accomplish. So, probably there are some apps that will be faster in Flutter if you have people that are skilled with Dart, and probably other apps that will be problematic with Flutter because you will need to access anyway the underlying system. Like, for instance, let's say that you don't have a library that can give you location, so you need to develop that yourself, so that might be trickier. The same can go with Kotlin, of course. The fact is that if you have Kotlin multi-platform, you probably have already two teams, and you just want to speed mm, to share as much code as possible. Um, so I wouldn't really quantify the time that you can save in both cases because that's really dependable on what you're developing. But usually, if you decide for Kotlin multi-platform, is mostly because you already have Kotlin developers. So if there are Android, probably it will be faster for sure. It will be faster on the iOS side because they wouldn't have to develop for the wall part for the shared module. But again, it really depends on what you're doing. Something that comes to my mind that could really be a good example for multi-platform is basically everything that is a news reading app. Let's say that you either have a REST endpoint or a GraphQL endpoint. It doesn't really matter because the logic will be always the same, and you will always get the models that you need and the whole repository, saving strategy, and everything can be achieved with Kotlin multi-platform, and you can take care of the UI in in iOS and Android, and that would be super easy to do because, as we saw, Ktor supports REST, and GraphQL is perfectly managed by Apollo, which has a multi-platform library. So that could be easier, probably.
All right, thanks, Roberto. We have another question here. Coming from the cross-platform side of an app development, Ionic, do you have any idea how similar or different is the developer experience?
Um, it is different. Well, the first difference is about languages because if you're using JavaScript or TypeScript, it's gonna be quite different if you go to Kotlin or Swift for many reasons. First, the type system is completely different. You're gonna end in a situation where you probably are would be super skilled in managing them in JavaScript or TypeScript, but they're very different in Kotlin. Basically, they have different weak points and different strengths. Also, when you're on Ionic, you can rely on different toolkits for your UI. I mean, everything that comes from JavaScript can be used, basically. Here, it's not really the case. So when you go on Android, you can either use the old view system or go to Compose. But again, there is a learning curve. The same goes with iOS. If you go to Storyboard or Layout Editor, or Swift UI, there is still a learning curve. Probably if you developed with React components, it would be way easier to start with components with UI because they are based on the same approach. Apart from some syntax and peculiar aspects of the UI framework, it would probably be easier. Um, Another thing that I think that would really change a lot is the IDE. Using Android Studio and generally JetBrains IDE for development is something amazing. Um, and dealing with Xcode might be slightly more painful than expected if you're not used to it, especially because all your key shortcuts, sorry, would be different. And when you try, for instance, to run your project, you open every place window, and you're like, yeah, why did that happen? So I think those might be the most important differences.
Okay, we have another question. Do you think that Kotlin multi-platform can replace Ionic? Another Ionic question from a different person. Different.
Um, well, totally biased answer. Yes, I hope so. To be honest, I hope it replaces everything else because I love Kotlin and I think it's a far superior language than anything else we've seen so far. Because it's simple, it's not bundled with any system, and can be updated pretty simply. So, coming from an Android background where we had to wait for Java 1.8 for 2 years, we could only use on a very specific version of Android. Well, Kotlin is a one we learn. Probably this is the same with JavaScript, but um, yep, I don't really like JavaScript, and as I don't really like Dart, and I can do almost everything with Kotlin. So my hope is that Kotlin multi-platform becomes the standard for multi-platforms app. But I think that it has a long way to go. I mean, we never mentioned Xamarin, for instance, but it's still widely used. I mean, why would you use Xamarin as of today when you have Flutter, for instance, or Ionic or anything else? But still, it's still pretty much diffused. I don't know why. And I hope that Kotlin multi-platform will replace them all, but still in beta.
Okay, I guess once you're into a particular language, leaving it, like you said earlier, Roberto, you kind of throw away some years of your of your life if you decide to migrate and build the
Yeah,
same product. Yeah, yeah.
yeah. Probably you can recycle most of your knowledge, but the automatism that you get in language. I mean, I've been working with Java for um, 8 years now, and after switching to Kotlin, I when I came back to Java, I was like, how does this language work? I don't remember anything at all. So literally, I spent minutes trying to understand why I couldn't compile my application. It was, of course, because I needed a semicolon, or because I was passing some Kotlin code and using var instead of the long declaration with Java. So I basically lost everything that I had with Java. Um, I think it's part of our job, but I love Kotlin so much that I hope it doesn't last. I mean, that it does last for a long time.
So there are no questions. I can ask another one to put you on the spot since you work for the New York Times. Are they using Kotlin?
Kotlin, yeah, we're using a lot of Kotlin. We
Ah,
have
okay.
the vast majority of the code base is Kotlin. We also use coroutines. So yeah, we're pretty focused on Kotlin right now. Unfortunately, we can't really delete all the Java code just yet. It's gonna be there, but not just yet.
Okay, let me check if there's any other questions. So, if anybody wants to go live and ask Roberto face to face, you can join the link provided here on the YouTube chat. It's a meetup link, so it should work immediately without any sign up. But if you have any problems, do shout out on the chat. So let's wait if there's anyone joining. So how's working from Turin and you are on a different time zone with New York, Roberto?
I have to say it has been rough at the first, well, in the first months. That was because I joined it without knowing anyone, so it really felt lonely at times. I have to say that all the teams that I've worked on at the New York Times have been um, wonderful, um, and they are super keen on respecting our time zone difference, and they plan meetings so that we never have to either wake up too early or stay up too late. So it's really nice. We've been having meetings over Meet for the past 4 years now. So we were already pretty used when the whole pandemic started. And yep, it has been rough at times, but now we are a few of us spread around the world, so it's
Yeah.
much easier.
Thanks for sharing, bro. We have one more question coming in. What's your main source website for improving your knowledge on Kotlin?
Uh, well, more than a website, I would say the Kotlin Weekly newsletter. It has often a bunch of blog posts that are really interesting, like one that was shared recently that I honestly still have to read, but in these days it's impossible to find the time. It's the one about the possible sunsetting of live data in favor of flows. Um, while this was not exactly news because we were all expecting that to happen, because when you see the flows and the state flow coming out, you really see that exactly like we replaced the observables and singles from RX Java with live data will be replaced with something else at some point. Um, but that was just an example. Another really important one is the Android Weekly newsletter. That's more focused on Android, but nowadays almost everything is related to Kotlin. So if you're curious about both Compose and Kotlin, those two newsletters are really, really interesting for what to read.
Yeah, it would be great if you have the links to share and we can put it on the events page, and
Yep,
so some of the audiences can go back and check on it.
yep. I share with you afterwards.
Okay, any last questions from anyone? Okay, if not, we do have um, a feedback form, I believe, if I can find it. Um, it's not on the slides yet. Have it on the slides.
Okay, I'll stop sharing my screen then.
Yeah. Here we go. Okay. So you, those are still with us. Much appreciated to get your feedback about this event. Um, like I said, it's a very short one. I think it will take, I think, 3 questions, so it'll take you less than about a minute to fill up. If you have any further questions about Kotlin, feel free to reach out to us. Or if you're interested in what we do at GDG Lausanne, again, reach out to us at any time. Okay, and lastly, I'd like to thank Roberto again for giving us this very interesting introduction to Kotlin. And I also hope that there will be more competitors out there and keep all the multi-platform software available actively being pushed by different organizations. We saw Facebook React Native, Microsoft Xamarin. So it's always nice to have competition. But having said that, there's a lot of complexity after that as well. Okay, thanks again, Roberto.
Okay, thank you
Have
for
a good
sorting out
evening.
my webcam switched off. So thank you very much for having me. It was really nice. I hope to meet you all in person at some point when this pandemic is over.
Yeah, we're not too far away. I think what, 2 hours drive, um,
Yep,
approximately.
yep, not that much.
Yeah. Okay. Give us a shout when you're in the city.
I will. So thanks again and good
Thanks,
night, everyone.
everyone.
Thanks.
Bye, everyone. Thank you very much.
Thank you.
Thank you.
Bye bye.
Bye.
Ciao. Bye.
Bye.
Good evening.